Variance. In the previous lecture, we learned about expectation of a random variable, expectation of x. This lecture, we are going to learn about variance, how to find the variance of a random variable x. So variance is a statistical measure that quantifies the spread or dispersion of a set of data points. That is, you are going to see how much does it deviate from your expected value, the expectation. Let us take our previous movie review example. In that case, we were considering ratings of 5, 4, 3, 2 and 1. And we had found that the expected value for the movie under consideration was 4.63. 4.63 was the expected rating. So how would you find the variance? The variance is to find how your data is spread from this expected value. Let us say there is a scale where you have values 1, 2, 3, 4 and 5, and your expected value is somewhere here. It is 4.63, right? It is 4.63. You want to see how your different data points that you have, how do they spread from your mean value? How much the values in data set deviate from the mean or expected value. This is what you want to find. And for this, the measure used is called variance. So this is how variance is defined. It is the expected squared deviation from the expected value. Let us write it down. Expected squared deviation. Squared deviation, right? From the expected value. From the expected value. Why I am writing this down is, from this it's easier for us to identify the formula of variance. How do you find the formula of variance of a random variable x? Expected squared deviation from the expected value. So first of all, let us find what is expected value. Expected value is e of x. That's how you write the expected value. What is deviation? That is, you have some expected value we said 1, 2, 3, 4, 5, and our expected value was 4.63, somewhere over here. So if you take any particular point, let's say there is one rating which was given 3. What is the deviation from the expected value? That is this distance. This is the deviation of the particular point 3 from expected value 4.63, right? So that would come out to be x minus e of x. This is the deviation. X minus e of x is the deviation that you have from the expected value. What is the next step? Squared deviation. So you have to square this. Then this is called squared deviation from the expected value. So the last term is expected. That is, you have to, now initially you found the expected value which is e of x. Then you found the deviation from the expected value which is x minus e of x, this term. And once you found that, you found the squared deviation from the expected value which is x minus e of x whole square. And the next step is to find expected squared deviation from the expected value. So you have to find expectation of this whole thing. This is what you call as variance. Variance is the expected squared deviation from the expected value, right? So now if you simplify this, that is, if you apply formula of a minus b the whole square here, I'm not solving this. This is very simple. You will straightforward reach here. You will reach expectation of x square minus expectation of x the whole square. This is where you will reach. So in order to find the variance according to your convenience, you can either use this formula where you first have to find the expected value of that particular random variable. Then for each of the values that this random variable takes, you have to find what is the deviation. Then you want to square those terms. Once you square it, you want to find the expectation of that squared deviation. Either you can use this formula, or instead you can use this formula where first you find the expectation of x, which is this term, expectation of x. Once you find that, you find expectation of x square. Then you subtract expectation of x square with that of expectation of x square. Right here you take the expectation and then square. Here you take the expectation of square of the random variable. So that's how you do it. You can either use this formula or this formula. Instead, if you simplify it, we know that the formula of expectation of x is summation over all x into p of x. This is the formula for expectation of x. If you apply this into this variance formula, then you will reach here. That is, variance of x is equal to summation from I equal to, let's say there are n points in total, so I equal to 1 to n, right? For each of the I, what do you have to do? You want to find expectation of this value, that is difference of that value from deviation. How do you find difference of that value from deviation? Xi minus mu, where mu is my mean, okay, mean or the expected value, both are one and the same, square into, what do you want to do? Probability of x. So put probability of xi. So this can be simplified to this form also, where what is this mu? Mu is your mean or expected value, that is sigma I equal to 1 to n, considering there are n points. You want to do xi into p of xi. This is your mean, okay? You want to use this mean value here in mu, okay? Then if you calculate this, that is sigma I equal to 1 to n, xi minus mu the whole square into p of xi. This is how you calculate this, okay? So you can use either of these versions. Either you use this formula or this formula. If you are using this formula for variance, then this is the way of calculating it, okay? And one special case is, what if the probabilities are all the values of your particular random variable, if they are equally likely. In that case, probability won't be significant. If all are equally likely, in that case, what can you do? In that case, you can simply take the average instead of taking expectation. So your mu instead of this will get converted into what? It will get converted into average, that is 1 by n sigma I equal to 1 to n xi, okay? So this is in case all the values of your random variable are equally likely. If all the observations are equally likely, then probability doesn't have a role because all are equally probable. In that case, this formula gets boiled down to average 1 by n into xi. And in the same case, what will happen to this one? Once you find mu, then you have to find the variance, right? So this variance formula, what will this get boiled down to? It will get boiled down to 1 by n sigma I equal to 1 to n, and again you will do xi minus mu the whole square. You don't have to take this probability because all the probabilities are same. And remember, in this case, your mu is this, and if all are equally likely, here your mu is this, okay? Right.